the first part is kind of explanation leading up to what we put in there. So we have a couple of empty spaces on our graphic organizer about congruent triangles. I wanted to remind you to make sure that somewhere on the front there, just so you remember it, is in the space, somewhere in the space there on the front, they write that angle, angle, angle doesn't work. So just so you remember that we can't use angle, angle, angle to show that triangles are congruent. So one of the bubbles there on your graphic organizer on the lower right tells us, it says AAS, and AAS stands for angle, angle, side. So you can put that in your bubble there in your graphic organizer. And we're gonna talk a little bit about angle, angle, side, and then we'll get to what we want to write about this. So we're going to look at this for a minute, because we can use angle, angle, side to show that triangles are congruent, but we have to be careful. And let's take a look at why. So I'm going to look at two triangles, and we're going to figure some things out about these two triangles. So I'm going to mark these. I'm going to say this is 60 degrees. This is 75 degrees on both triangles, 60 degrees and 75 degrees. So this, again, this is not what's going into your graphic organizer. I just want to do a little bit of explanation. And we know that this side is congruent and that side is congruent. So from what we've learned up till now, we wouldn't be able to, this doesn't fit with side, angle, any of those, because our side isn't between the two angles. It's not the included side. So we can't use side, angle, side here. This is angle, this would be angle, angle, side. But what can we figure out about these two triangles? What's the same? The angles. The missing one, the one that's missing. So we can figure out, because all of our angles have to add up to 180. So if we add these two up and subtract from 180, what do we get? Anybody know? Anybody have it? If we add these two up, these two add to 135. So we subtract that from 180 and we get 45 degrees. So these two angles are 45 degrees. Now if we look at our triangles, what combination do we have down here? Now we have angle, side, angle. So by figuring out this third angle, we've turned this into an angle, side, angle combination. So angle, angle, side can lead us to angle, side, angle. So in this case, angle, angle, side does work. Now we would have to be careful. Right, we've changed it to angle, side, angle. So what we've done is, if we have the triangle set up the right way, we can turn an angle, angle, side into an angle, side, angle. So if we have angle, angle, side, and we'll talk about where we have to be careful, then sometimes it turns into angle, side, angle, but not always. So in our graphic organizer, we're going to say that angle, angle, side, first, it's not a postulate, it's a theorem. Because it comes, if it works, it comes from angle side angle. That's what we just looked at. So what's going to go into our graphic organizer is we're going to say, just like we did before, this is, and I'm just rewriting what I wrote on the top of the last example. This is angle side theorem. So just like we had before, we have two triangles. If two angles and a non-included side, or side isn't between the angles, are congruent, then the triangles are congruent, and this is where we have to be careful though. If the parts are in the same order, and that's the important thing about angle side. Our parts have to be in the same order. And then we'll look at an example of what we mean in just a second. But this is what's going to go into your graphic organizer. Two angles and a non-included side. The sides not between the angles are congruent. The triangles are congruent if the parts are in the same order. So this is where we have to be careful with angle side. So this next example is really the important one for angle side, because we'll show why we have to make sure the parts are in the same order. All right, any questions on this part? Okay, so let's look at why we have to be careful. So we're going to set up our triangles like we did last time, but we'll make a slight change. So I'm going to say these sides are congruent. This is 60 degrees. This is 45 degrees, just like before. And we can figure out, just like we did before, because they all the angles in the triangle have to add up to 180. This angle is 75. And this angle is 75. Can we use angle side here? Did this turn into angle side angle for these two triangles?
Yes.
On this triangle, the side is between the 60-degree angle and the 75-degree angle. On this triangle, it's between the 45-degree angle and the 75-degree angle. Does everything match up in the same order? No. This side would have to match up with this side in order for it to work. The congruent sides aren't in the same order, so we cannot use angle side. So we can't use angle side. So this is why we have to be careful with angle side. If our parts don't match up in exactly the same order, we can't use angle side. So sometimes, even though we have two angles and a side congruent, the triangles might not be congruent because our parts don't match up the right way. So that's why we have to be careful. Questions on that example? All right, so what I want to do next is I'm just going to draw up some triangles with angle, angle, side, and we'll decide, can we use angle, angle, side, or can we not use angle, angle, side? Yeah, Chris.
Now, so 26, 75, 26, 75, 45. Wouldn't this also be angle side angle? Because that's right instead of being angle angle side. Because angle side you have two angles, like angle angle side, right?
Mm-hmm.
Okay, so it would be angle side angle.
You can't, it could be angle, side, angle, but we have to match up the same angles. So on this triangle, the two angles, we match up the 75-degree angles here, but the other angle that's next to my side is 40 here. So I'd have to match up this 60-degree angle with this 45-degree angle.
So if we were to move the mark over to where they're matching up over there,
Mm-hmm.
will still be side angle side? Or angle side angle?
If the tick mark on this triangle, instead of being here, were here, then yes. But because it's not, because the tick mark is not there, it's over here, then it won't work.
So even if the tick mark's over there, it still would be angle side. Because it'd be angle side angle.
Yes. But if we, let me redraw this. If we had our triangles like this, and I'm just going to redraw it just differently, and I think this is what you're asking me. So if we had 60 and we had 45 on both triangles, like so, and we had them like this. Is this what you're asking, Preston? If we had it set up like this?
Yeah.
This would be, we could use angle, angle, side here because our parts match up in the same order. The tick mark here is next to the 60-degree angle here, and it's next to the 60-degree angle here. So we could use angle, angle, side here. So this would be yes. Angle, angle, side does work. So if our tick marks line up this way, then all of our parts are matching up in the same order. We have the side that's congruent next to the 60-degree angle here, the side that's congruent next to the 60-degree angle there. So the parts match up in the right order on these triangles. But because on these triangles, the congruent sides are not next to the same angles, they don't match up in the right order. And we're going to look at some more examples of when it works and when it doesn't. That's what we're going to do next.
Yeah, I mean, when you have the 75 up top,
Mm-hmm.
because if you start with 25, the angle side is angle, and not, yeah, like that. So how do you know? So if you have the like bottom example, and the top two still match up with 75,
Mm-hmm.
how would you know if it's angle side angle or angle side?
So if you have this problem and you said angle, angle, side, you would be correct. Before you said angle, angle, side, if you figured out that that each of these was 75 and you said angle, side, angle, you would still be correct. Both ways would be correct.
Okay.
So either answer you gave would be fine. Okay, does that help?
Yeah.
Okay. The nice thing about angle, angle, side is if our parts match up in the right order, then we don't even have to figure out that. Okay? All right, let's look at some other examples. So we're going to draw some triangles up, and we will decide, can we use angle, angle, side? All right, so here's our first one. And I'm going to mark these triangles like so. Can we use angle, angle, side on these two? Ray says yes. Do the parts match up in the same order? The tick mark is next to the angle with two tick marks. So we can say yes, we can use angle, angle, side because our parts match up in the right order. All right, let's look at another example. So I'm going to draw my triangles, and in these, it's really important to remember as we work through these, in this chapter especially, that it doesn't matter what it looks like, it matters what the information is that you have. You have to go by the information that they give you. So I'm going to mark this one like so, and this one like this. I see some no's. Do our parts match up in the right order? No, our tick mark here is next to the angle with one tick mark. Our side tick mark here is next to the angle with two tick marks. So this would be a no. They don't match up in the right order. All right, let's try to make them a little trickier. So I'm going to do this one so, just like we've done before, and I'm going to do this one like this. Oops. Do the parts match up in the right order?
No.
Have a few yeses and a few nos. Another yes? So, remember what we said, we talked when we said how we define congruence? If we can translate, rotate, or reflect the angles, the shapes, and they're the same. So if I take this triangle and I flip it over on top of this one, I'm going to take it and do that. Do they match up? If I flip it over, they're going to match up. So on this triangle, the tick mark is next to the angle with 2, and on this triangle, the side is next to the angle with 2 tick marks. So this would be a little trickier. This one would be a yes. I can flip this triangle over on top of that one, and the parts match up in the right order.
You can just like flip it like that.
Yep, just flip it over, just like you're turning it over. So that one would be a yes. The parts do match up in the right order. Let's do one more. So here we're going to mark one like so. How about this one?
Yeah.
A couple of no's, a yes,
No.
more no's. So our tick mark is next to the angle with 2 tick marks. Here our tick mark is next to the angle with 1 tick mark. So if I rotate this way and slide it over, rotate it and then slide it over, this side is going to end up right here. So this would be a no, because the parts aren't in the right order. So this one we're going to rotate it and slide it, and the sides don't match up. The sides wouldn't be in the same position on both triangles. So with angle, angle, side, we have to make sure that our angle, angle, and side are in the same positions on both triangles.
Is this only for angle side angle?
Only for angle, angle, side, yes. For angle, side, angle, 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 side, or I'm sorry, angle, side, and side, side, side. As long as those parts match, then we're okay. Okay? All right, so we have one more bubble. Yes. We have one more bubble to fill in on our graphic organizer. And that's what we're going to do now. The next bubble says HL. And this HL is a theorem, and it stands for hypotenuse leg. I misspelled this. So this is what the title of your bubble. Now before we fill in, like we did last time, before we fill in the bubble for a hypotenuse leg, I want to talk about a few things. One is another reminder that should go in the space on the front of your graphic organizer. We're going to say there's one combination of sides and angles that we also can never use, just like angle, angle, angle. I'm going to say SSA. Side-side angle. Side-side angle doesn't work. So if we have two sides and an angle that are congruent, we can't use that to show that triangles are congruent. And I'm going to put in parentheses here, usually. Because in our bubble we're going to talk about the one time that it does. An easy way to remember this side-side angle is that it doesn't work is if you rearrange these letters, you get a word that you shouldn't say in geometry class. The side-side angle doesn't work. You rearrange it and you end up with something that you don't want to say in your geometry class. Now what I want to do is show you why side-side angle doesn't work. So here is a triangle. And here is the angle that we're looking at. And here are the two sides that we're looking at. So I'm going to make another triangle that has this angle and these two sides that is not congruent to this triangle. So I'm going to say I here. So I'm going to grab my compass. And I'm going to put the point here on this side. And I'm going to move it down. Rotate it down. And put the other point right on the length, right on that side. So my compass has opened the exact length of this side of the triangle. Now, I'm going to draw a nice little curve here. So right where my compass touches the bottom, the base of this triangle, it's open the exact same length as this side. Now I'm going to move my compass and draw in a line right there where they connect. This side and this side are the exact same length. It has the other side that's the exact same length, and the angle, this angle is the same. That angle didn't change. Oh, this construction? No, this is this is a different construction than was on the test. So this little triangle is not congruent to the big triangle, but it has the same two sides and the same angle. I can swing this side around and it touches this base in another place. So I have two triangles. So this is why side-side angle doesn't work. I can make two triangles out of that combination of sides and angles. So we don't know for sure whether we have one triangle or two triangles. Now the reason I wrote usually here, and this comes back to our hypotenuse leg. The one time that this does work, that that side-side angle will work, and let me draw the triangle here. And this is a 90-degree angle. Here's my angle, here's my side, here's my other side. So I'm going to try to do the same thing that I just did with my compass. So grab the compass again, set it on that side, swing it down so it's open the exact length of that side. And look what happens now when I try to swing it around and connect to the other side. It won't connect anywhere else. So if I have a right triangle, SSA does work. But instead of SSA, instead of calling it SSA, we call it hypotenuse leg, because this is the hypotenuse of my right triangle and this is the leg. So here's what we're going to write into our bubble for hypotenuse leg. I was just showing you why we can't use side-side angle, but why hypotenuse leg does work. So in our bubble, we're going to write for our hypotenuse leg. Start with two triangles. Two right triangles this time though. Hypotenuse leg has to be with a right triangle. Two right triangles. If the hypotenuse and leg are congruent, then the triangles are congruent. And remember, on a right triangle, the hypotenuse is always the longest side. And the leg is, in either of the other sides we call legs. The other sides are legs. So side-side angle works only with right triangles, and in that case we call it hypotenuse leg.
One leg triangle?
As long as we have the hypotenuse and one leg, then we are good with hypotenuse leg. So if we look back here, if I have another triangle, if I know that if I have two triangles where, let me redraw another one down here. And it doesn't look exactly the same. So if I know that these angles, I know this angle is congruent, in a right triangle we automatically have the 90-degree angle. So then we can figure out the third angle. So we have angle, angle, side, or angle, or sorry, side, angle, or side, angle, side, because we can always figure out that third side of our triangle. All right, let's look at one example with hypotenuse leg, and then we are done. And our graphic organizer is filled out. We want to know, are these congruent? And if so, why? So here's our picture. And this is a 90-degree angle here, and this is a 90-degree angle here, and we have those two sides congruent. So would these two triangles be congruent? heard a couple of yeses. So the way I have these two triangles set up, what else do we know about these two triangles?
The side in the middle.
The side in the middle is congruent to itself. Do you remember what we called that property? Starts with an R. Reflexive. The reflexive property says things are congruent to themselves. So this side that we already marked is the hypotenuse of these right triangles because it's the longest side, and here's a leg. So our right triangles are congruent by, yes, by hypotenuse leg. And it's important to remember with hypotenuse leg only works for right triangles. We can't use hypotenuse leg on any other triangle but a right triangle. Questions? Okay. Let me, because we're going to be doing our activity a little later, let me make sure I put the homework up so you guys don't forget to get your homework. So make sure you write this down, page 231. So there's the homework.